Now we're looking at, in section 6.4, proving triangles similar by angle, angle. So our first method in showing similarity. We'll actually have two others in the next section, but this one is angle, angle. So this similarity postulate reads, if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So let's write out what we have. So if we write this by our diagram, we have angle J is congruent to angle X, and angle K is congruent to angle Y. Then we have the two triangles, JKL is similar to X, Y, Z. So just by having two sets of angles, we know we have similar triangles. It's enough. Now it's not angle, angle, angle. If we knew the third angles, well, yeah, those would work too, but we don't necessarily need them. Let's just think of a quick example why we don't need them. Let's say I have this angle is 40 degrees, this angle is 100. If they're both congruent, well, so that would also be 40, and that would also be 100. The third angle on L would be what's left over to get to the sum of 180. Well, 40 and 100 would leave me 40 left over. The third angle for Z would be what's left over to get me to 180. 40 and 100 would leave me 40 left over. I don't necessarily need it. We even go back to the third angle theorem. If two sets of angles in congruent triangles are the same, then the third angles are the same. 2 is enough. We only need those two. So as we go through looking for similarity today in this section, we're just going to look for 2. If 3 work, that's great. We may want to mention the third one just to help us, but again, we only need 2. So let's just jump in and get through some examples that gets us looking for similarity. Now, it's called angle, angle. I'm not looking for any sides. We'll get to that in the next section. Right now, we're just looking for 2 pairs of angles that match. So our first example says, determine whether the triangles are similar. If they are, write a similarity statement and explain our reasoning. So we look at what we have. Well, first off, I see that they're right triangles, or right angles, so I know angle D is congruent to angle G. Okay, I also have that C is 26 and H is 64. Well, I can clearly see those are not the same. But you know, what would angle E be? So if I took 90 and 26, I would get 116, and then subtract that from 180, I would get 64. So that means E is 64. Well, then therefore E is congruent to angle H. They're both 64. Well, if I did the same thing over with HGK and did 90 plus 64, I would get 154. Subtract that from 180. I would get 26 for angle K. Well, now I see angle K and angle C are also the same. Well, I just found 3 of them. I don't need all 3 of them. I need 2 of these. If this was a problem where you were solving it, you would just name 2 of them and give your reason. They're right angles. Right angles are congruent. And then we found the third angles using triangle sum in each triangle to find that those match up. Okay, so that's how they work. And now we need our similarity statement. So let's call our first triangle CDE. That's similar to, well, let's see, if C was my first letter, K needs to be my second letter, my first letter of the second triangle. KGH will be my name of my 2 triangles, CDE, KDH, and those are similar by angle, angle. Okay, so we identify, that's how they're similar. Now if we look down at the bottom half, we didn't label our points here, so we're not going to get too specific in naming it, but this is a good example to see what's going to start to show up when we need to find our similarity. So what I know here, I have some side values. I can't use those yet in angle, angle. I'm going to get to those. If it is in fact similar, they're going to help me find the value of P. But just by what I know, I see two lines intersecting, those points of the triangle, or the sides of the triangle, and I see parallel lines. Now these are good clues for what we're going to get from this type of diagram. First off, I have vertical angles. I know vertical angles are congruent, so that would give me one angle pair. So if we see a type like that, go with the vertical angles. That works. I also have parallel lines, so that gives me alternate interior angles. That would give me two angle pairs. I have enough to say that they're similar. In fact, well, these would also be alternate interior, so even those would be enough for alternate or for angle. But I know it's similar, so we're going to say yes. And now I need to find the value of p. Well, I need to make sure I set up the proportion. It's really tempting. Do I do 10 and 24? Do I do 10 and p? Well, let's just say I start with 10. I want to find its corresponding side. So the side over on the other triangle that corresponds to 10 has to be kind of in the same position as this 10. Now this 10 is between the single and the double angle marking. That means its corresponding side needs to be between the single and the double angle marking. Okay, well that's P. 12 is my other side in that first triangle. That's corresponding to 24, really our only value left. So that's going to be my proportion to solve. I could do cross product from here and say 24 times 10 equals 12p. 240 equals 12p. So p is 20. But also, if you wanted a little bit of a shortcut, I can reduce 12 over 24 and make it 10 over p equals 1 over 2. And by doing cross product for that, I would also get to 20 equals p. I just want you to be aware that you can find that shortcut when you reduce with your proportions. So, there's my value. When you see these types, look for the vertical angles, look for the alternate interior. They will help. It's a certain clue that comes along, and take advantage of it. Okay, now we're looking at some others. We need to show how these two triangles are similar. We're going to write it a little close to a proof and just organizing our thoughts and planning things out. So I have ABE is this small triangle, and ACD is this bigger triangle. It's almost like the small triangle is laying on top of the bigger one. I'm going to start with what I know. I know that angle ABE is congruent to angle C. Well, that's given to me. They're both 52 degrees. Okay, now I need something else. If I look at E and D, I don't know much about them. I don't know anything at all, really. So I can't do anything there. If I look at the peak, though, of each of them, I have that angle A is congruent to angle A. Well, this is going to be our reflexive property. This angle appears in both triangles. So, there's an angle. There's my other angle. Let's mark this one. That's enough now to say that triangle ABE is similar to triangle ACD by angle. Our next one. Okay, well, I have V is where the two triangles meet. I have parallel lines. This looks like a lot like the one we just talked about. I know that angle S is congruent to angle U. I know angle R is congruent to angle T. I know each of these are alternate interior angles. So let's mark them accordingly. Now, if I adjust that information, that's enough to say they are similar. But I really have one more, and that's at V. And that's angle SVR is congruent to angle UVT. And those are vertical angles. Now, like I mentioned earlier, we kind of went above and beyond. We only needed two, but we found three. It works. It doesn't change anything. If you found two of them, I would stop and just get to your answer and stating them congruent, but it's good to be aware when the options come up. So, triangle SVR is similar to triangle UVT by angle, angle. Okay, let's look at one more example here. Kind of a different approach to what we have. Let's say we have someone is standing out looking at their shadow, and our person here is, let's say their height is 4 feet 6 inches. That's their height. And they look at their shadow, and their shadow goes out 3 feet. At the same time, they look at the shadow of a flagpole, and that shadow is 20 feet. What we want to see is, can we find the height of the flagpole? Let's call that x. Now, using angle, angle, this is possible, but we need two sets of angles. So, first of all, the person and the flagpole, we're going to say, are standing straight up. So we're going to say they're perpendicular to the ground. So there's a set of angles. I have my right angles. Also, if I look at the way the sun is coming in, so the tip of that shadow, and extend out this side, these are going to be the same angles. This top angle the sun hits it at. So the sun's rays come in, they hit the top of the object, and they form the shadow. So this type of problem now lets me set it up, because they are similar, by angle, angle. So I have 4 feet 6 inches. Now 4 feet 6 inches I want to write as a decimal. 4 feet 6 inches is 4.5 feet. It's not 4.6, it's 4.5. There's 6 inches in a foot. So 4.5 feet. So I'm going to say 4.5 feet is to the height. The height of the person is to the height of the flagpole, so x. That is equal to the shadow of the person to the shadow of the flagpole. So 3 to 20. Now, I could have said 4.5 feet to 3 feet equals x over 20, and it still will eventually work out the same, but we're just going to go with this one. So we were going the person to the flagpole as our ratio. So now we can solve it. I'm going to do 4.5 times 20 equals 3x. 4.5 times 20 gives me 90 equals 3x, and x would be 30 feet. So the height of the flagpole is 30 feet. Now we got to that by using our angle, angle, but it's good to start to work with problems and